we're going to have an easy time with this section because slope is rate of change. Because what is rate of change? It's how does the graph grow, how does the line grow as x changes? In other words, how does y change over x? Well, if you look at different lines, let's say I draw a couple lines on here, so if I have this line versus this line, which of those has a steeper or a bigger slope?
The first one.
Okay, the first one I drew, right? This one right here is a steeper slope, okay? Now, the easiest way to recognize that it has a steep slope by looking at points is if you look in like this graph from this point to this point, as x changes by 3, y increases by about 3, right? But in this graph, as x increases by 3, y only increases by a little over 1, right? So the steeper a line is, the greater the change in y is going to be compared with the change in x. If over a small distance on your x, y changes dramatically, then you're going to end up with a very, very steep line. If over a small distance on x, y barely changes, then you're going to end up with a line that's fairly flat. Okay? So, slope is going to be described by a number, and that number is going to be the rise of the line over the run of the line. Now, you need to get familiar with this phrase, rise over run, but once again, you've already been doing this. What controls how much a line goes up and down? Where a point is, up and down. Okay, but what part of those points controls its height? Not x and y. Just y, right? Y is the only, x could be 7 or x could be 0, and that doesn't change your height of your point, right? X controls where it is left to right. Y is what controls your height. So our rise is going to be what's going on with y. And to find out how much it rises, we're going to have to find the difference in the y values. The run means how far in the graph we're going left to right, which is controlled by x. So to find the x, we're going to have to find to find the run, we find the difference in the x values. Now this is the equation for finding slope if you're given 2 points. This says to find slope, we find the rise, which is the difference in the y values, over run, which is the difference in the x values. Does that look familiar at all? Okay, have we done something where we subtracted the y values and then subtracted the x values and put one over the other? Yeah, what is that? Rate of change, okay? Slope is just rate of change, okay? So, if I gave you 2 points, and I ask you to find the slope, it's the same as if I gave you 2 points and asked you to find the rate of change between them. Okay? When we're dealing with slope, we're looking at straight lines, so it's going to be a constant rate of change. So all you have to do is pick one of your y values. So which y value do I want to do first? -4? All right. So we're going to do -4 minus 6 over 3. I have to do 3 first because negative 4 was my first y value, so 3 has to be my first x value. So I do 3 minus 1. Negative 4 minus 6 is negative 10. 3 minus 1 is 2. This is divisible, so I can divide it out, which gives me negative 5. This line has a slope of negative 5. Oh yeah, I told you, this is easy stuff. Alright, now, that's one of our 2 objectives, being able to find slope from 2 points. If you're given 2 points, find the difference in their y values, find the difference in their x values, and subtract. And divide. So, yes?
On this paper, is the A x and the B y?
No, that's point A. They're just naming the points. You have negative 10x, 6, and you have negative 5a. Those are the 2 points. That's like if I said this is point A and this is point B. They just named the points. Did you already do it? Put it in test models? Okay. Just set it in that. No, put it away. All right. Okay, so the other thing that we need to be able to do from this section is to be able to find a slope from a graph. So let's say that I have, I'm going to make a different size graph paper here, easier to see. All right. So let's say I have Alright, so let's say I have this graph and I have a line that looks like Alright, so let's say I have this line. And I want to find the slope of this line. Now, to find the slope of the line, I want to find rise over run. Now, there's technically 2 ways we could do this. One way is I can pick 2 points on the line, and I can do the y value of one minus the y value of the other over the x value of one minus the x value of the other. You can do it that way. You can pick out 2 points that are on line, and then use those 2 points. Or you can count. Yes, that's right. Your homework tonight involves counting. It's like you're back in elementary school, okay? Now, if slope is rise over run, start at 1 point on the line. Pick any point that's on the line. For instance, this point right here. Now it needs to be exactly on the line, so it can't be like this one right here where it's, oops. Sorry. I don't want to use like this one because it's not exact, like I don't know that value, right? I mean, I know that it's negative, the y value is like -1 and maybe a fourth or something, but I don't know exactly, right? Guys, why are y'all talking while I'm teaching? It's being very rude. Now, and you shouldn't be working on homework either. You can hold your horses. You'll have time. Now, you want to pick 2 points that are on the line. They need to be exactly on the line, so you need to have an exact point. So, for instance, I have that value. What is that value? Who can tell me the name of that point?
-6, -2.
Alright, so -6, -2 is on the line, right? Alright, so what's another point that's on the line that you guys see? That 0, 2. That's on the line, right? Now, like I said, one option is I can do the y value minus the y value. So 2 minus negative 2 over 0 minus negative 6. And I can find my slope that way, right? The other option, though, like I said, involves counting. Start at one point, and from there see how much you have to rise to get to the second point. So if I start at this lower point, to get to this point, I have to go up 1, 2, 3, 4 units, right? So this has a rise of 4. Then, to get from that same point over here, I have to go to the right 1, 2, 3, 4, 5, 6 units, right? Yes? Yes? Okay. So, my run would be 6. So, since slope is rise over run, I get a rise of 4 over a run of 6, which is 2/3. So the slope of this is 2/3. Now if we look, if we did it using the points, what's 2 minus negative 2? 4. What's 0 minus negative 6? And I get 4/6, which is also 2/3. So either way will work. Yeah, slope should be simplified. So yes, Josh. You don't make them into mixed numbers. We do want a slope to be fraction because it's rise over run. If you make it a mixed number, then it's no longer rise over run. Then you have this whole number that doesn't really mean anything. So you can make it into a whole number if it divides out evenly, but never make it into a mixed number. All right, let's look at another example really quickly. I said you can make it into a whole number, just don't make it into a mixed number if it divides out evenly. All right, so let's say I have this line. All right. So the first thing I need is 2 points that are on the line. Again, I always want to use exact points, not things that are kind of around. So, yeah. 2, -1. Yep, that looks like a good point to use. Does everyone agree that that's exactly on the line right there? All right. So then we need another point that's also exactly on the line. I think another good example would be this one right here, which is -4, 1, right? So to find my slope, I want my rise over my run. So I'm going to start with this point. To get from here to here, how much do I have to rise? To get from this point to this point, how much do I have to rise? I heard somebody. -2. Be careful, remember, negatives and positives matter. So if I'm going down, that means I'm rising a negative amount. So my rise would be -2, and my run would be what's my run there? 6. It's to the right, so that makes it positive. Right and up are positive, right? This is where my positive x values are. This is where my positive y values are. Down and to the left is negative. Now, -2/6 simplifies to negative 1/3. So the slope of this line is negative 1/3. Now, one suggestion I make, the biggest thing that I have students mess up on in this is that they get the slope right, but they make it negative when it's supposed to be positive, or positive when it's supposed to be negative. Here's the thing that I recommend you do, and if you do this, if you take seriously like 2 seconds to do this on every problem, then you should never get the wrong sign. So let's say I have this right here. Oops, I don't want that. Ah. All right, so let's say I have this graph. Now, lines have different kinds of slopes. There are actually 4 different kinds of slopes. Now, let's look at what those slopes are. Actually, let's do this. Alright, I'm going to change these colors up so we can refer to them easier. Alright, so what about this blue line? What's its slope going to be? Do you think that has a positive slope or a negative slope? Positive. Why do you think it has a positive slope? Okay, right. It goes up and it goes to the right, which are both positive directions, right? Now, I also, since I always think of ski slopes, I always think of my little skier. Is this guy about to go down a slope? No, he's about to hop on the ski lift, right? He's going up. So he's going in the positive direction. Okay? Now, if I take my same little guy, let's see if I can do this. Oh, come on. Can I get all of them? Oh, no, too much. Hang on. This worked better on my other program. Oh, there you go. All right. So, is he going? He has to be going up. I mean, this slope goes up, right? Now, sorry. This really did work better on my other one. Now, if I put my same little skier guy on this line, what's this guy doing? He's going down. Okay. What direction do you read, Thomas? So why would you look at the graph going this direction if that's the opposite of the direction that we read? That is a good question. Okay, if my little guy is over here on the left, which is where he would start because that's where we read from, then this graph is going up. This graph, this line is going down. Okay, what about I'm trying not to. Now, What about now? Now he's cross-country skiing, right? So what's the slope? Okay, right. The slope is non-existent, right? So this line has a 0 slope. This happens, let's look at what a 0 slope looks like as far as points go. If I find the difference between those 2 points, yes, there. Yeah. Huh? Do what? Oh, you're right, it is. Sorry, the program doesn't always cooperate. But yes. All right, yes.
Notice is if any of you guys have watched The Matrix, there is no slope.
All right. Now, it's a good movie. All right. Now, guys, so a 0 slope, which as David pointed out, mine's not exactly a 0 slope because my lines don't always cooperate. So yes, technically it did actually go up just a teeny tiny bit, but assuming this were actually flat like I intended for it to be, then this would be a line with a 0 slope. If I pick 2 points on this line, this would be the point 2, 3, and this would be the point 2, 3, 4, 5, 5, 3. Guys, so if I take those x and y values and I subtract, then I end up with 3 minus 3 over 5 minus 2. In other words, my change in y is 0 because my y value stays the same. If it's a straight line, horizontal line, there isn't a slope. My change in x is 3 here, but it really doesn't matter because what's 0 divided by 3? 0, right? How many groups of 3 can you make out of 0 people?
0.
None. You can't make groups of 3 out of no people, right? Okay. Now, that leaves us with our last line. Uh-oh. I left his head behind. I'm just going to draw a new head on him now. All right. He flinched himself. All right. Harry Potter reference.
You already had this in
All right. Now, what about this line? What about the slope of this line?
It has no run, so there's no slope.
Okay. Now, this is a really unique one, okay? When you have a vertical line, it's not a 0 slope because a 0 slope means that it's flat, okay? And remember, as the line gets steeper, the number that represents it is going to get bigger and bigger, right? Because we're going to end up with a greater change in y over a smaller change in x. But this line, the change in y is infinite. You know, we could look at the smallest y value, the biggest x value. You have an infinite change in y over no change in x. This line, this slope is what we call undefined. Guys, you need to make sure you know the difference between undefined and 0 slope. A 0 slope is a flat line, okay? That has no slope. The cross-country skier, okay? He has no slope, okay? The undefined slope is the crazy kamikaze guy about to jump off of the side of a cliff, okay? Now, undefined, guys, there's a lot of chit-chatting going on while I'm trying to teach today. I don't appreciate it. Now, an undefined slope, if we look at 2 points on this line, let's say I pick that point and that point. Now this point is, let's see, 1, 2, 3, 4, 5, 6, 7, 8, -2. And this point is 8, -5. If I try and find the slope between the points 8, -2 and 8, -5, what's my change in y? Change in y, -5 minus -2 would give me,
-7.
Oh, couldn't you do like, make that plus, negative, like, do the plus, and then like, make, you know how you can do a
I can make this plus +2.
Yeah, that's what I do.
That's fine.
And then you get negative.
Now, so then I get -3, but my change in x is 8 minus 8, which is 0. Now, has any of you ever, so then we end up with -3 over 0. Has anyone ever tried putting something divided by 0 on your calculator?
Error.
Okay, right. It gives you an error message, okay? Undefined lines will give you an error message if you try and calculate them out because you cannot divide 0 by anything. Now, the best way I can make to think, if you think about division as grouping, right? Right? That's how we first learned division, you learn grouping. So if I have, say, 12 divided by 0. So let's say I have 12 textbooks, and I want to put them in stacks of 0. How many stacks can I make?
0.
No? I could make an infinite number of stacks, right? Like, oh, look, here's a stack of 0, and here's another stack of 0, because a stack of 0 has nothing in it. So I could make an infinite number of stacks of 0, and the reason, though, that the answer is not infinity is because I'm still trying to divide 12 by 0. So if I have my 12 books and I'm trying to see how many stacks I can make an infinite number, and I still have 12 books that haven't been put in the stack, right? This is why division by 0 doesn't make sense. That's why your calculator gives you an error message, because it doesn't make sense. You can't talk about dividing something by 0 because you can't split it up into group size 0. Group size 0 doesn't split it up at all, right? So anytime you have division by 0, that is undefined. 0 divided by something, on the other hand, does make sense. If I have no textbooks and I want to make groups of 12, how many groups can I make? None, right? If I have no textbooks and I want to say how many groups of 12 I can make, well, that's pretty easy. I can't make any because I don't have 12 textbooks. So, don't get these two confused. Something divided by 0 is undefined. 0 divided by something is 0. This is a horizontal line, no slope. This is a vertical line, undefined slope. Okay? All right, you have the remainder of time to go ahead and start on your homework.
Yeah, Jack.